Do most planets harbor potential life? Chapter 1. The Arithmetic of Breathing Worlds. The question arrived like a pebble tossed into a quiet pond. Do most planets harbor potential life? It sounds simple enough, a yes or no that could be printed, framed, and hung above a school chalkboard. But when you say it out loud, do most planets harbor potential life? You are actually calling the universe to the witness stand. You are asking ancient stars to step forward and testify, asking unremarkable rocks to open their sealed diaries, asking blind oceans to tell you what they dreamed before eyes were ever invented to look across them. The universe doesn't answer in words. It answers in statistics, in chemistry, in patience. It answers by putting you in a chair, turning down the lights, and projecting the last 13,800,000,000 years of context across the back wall of your skull. So sit with me for a moment. Breathe. Let's make the question more precise, more human. When we say harbor potential life, we don't mean thriving civilizations with air traffic control and sarcasm. We mean something softer, wider. Conditions that are favorable, forgiving, fertile, chemistry that can get interesting if given enough time, environments that don't murder possibility in the first 10 minutes. We're looking for seed beds, not orchards. We're asking whether the universe scatters fertile soil lavishly or hoards it like gold. It begins with arithmetic, not the kind that turns your palms clammy, but the kind that has rescued lonesome hearts on long nights, counting the stars and the places they might call home. Somewhere along the curve of your life, you learned that our sun is a star among many, that the milky river that smears the country sky is not cloud but congregation, the combined glow of hundreds of billions of suns. Perhaps you learned later, with a second delight that felt like a door flinging open onto a larger balcony, that most of those stars have planets. Say that sentence again, as if saying it could change your blood. Most stars have planets. Once upon a time, scientists were careful, perhaps skeptical. Planets were tricky neighbors to confirm. They liked to be bashful in the glare of their host stars. But one by one, the shyness yielded. We began to see the cosmic wobble of a star tugged by an orbiting companion, the delicate wink as a planet slipped across the stellar face. We learned that planets are not a rare garnish, but the dish. Big planets huddled close, tiny worlds flung far, architectures we never would have invented if we'd been in charge. Our solar system, once presented to us as a sort of model home, turned out to be one haircut among many. When you harvest numbers from this orchard, you start to see a pattern. Exoplanets are not rare, they are abundant. Terrestrial-sized ones rocky, with the moods and mineral appetites that rock imposes, are everywhere. And around certain types of stars, humble, long-lived red dwarfs. For instance, habitable zones nestle close, where water could remain liquid on a surface under the right atmospheric quilt. It's not proof, it's possibility. But possibility is the father of potential. Now, before we do the easy math, this many stars times that many planets times such and such fraction in the gentle sash of starlight where water can run. Let's be sober about the word habitable. The phrase conjures a seaside, cottage, breezes, shade. A setting Sunday space has no such romance. Habitability is negotiation and contingency. It's the fragile handshake between a star's tantrums and a planet's defenses. It's often a war. A planet's atmosphere can be a lung or a suffocation. Its magnetic field can be a shield or a shrug. Volcanism can cook an atmosphere into being or burp it into oblivion. Oceans can embrace a climate or drag it down a spiral of ice. And yet this is what matters. Life does not require paradise to spark. It needs energy streams and a chemistry set. It needs time. It needs just enough permission to misbehave. Of all the provinces of habitability, water seems a trustworthy governor. Not because life could not, in principle, choose another solvent, ammonia, methane, something stranger, but because water is unreasonably gifted. It's a champion of dissolving, a generous partner in reaction, a master mover of heat. Water is boring as a word and tyrannical as a criterion. So much so that we build the first scaffolding of our search around it. Find the zones where water lingers as a liquid, and you have found the neighborhoods where chemistry can talk long enough to become autobiography. But water alone is a shallow invitation. Let's expand the guest list. Put energy on it: sunlight for photosynthesis, chemical gradients for chemosynthesis, geothermal leftovers from a planet's accretion and differentiation. Add essential elements: carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. Add complexity: cycles that shuffle these elements around in endless games of lend and borrow. Carbon cycles, nitrogen cycles, weathering cycles. Add stability: a climate that doesn't flip the table every few million years without warning, or at least a refuge when it does. Add surfaces: the interface where stone and water and gas negotiate and sometimes conspire. Add depth: porous rocks, ocean bottoms, mineral cliffs in cavern darkness where tiny electrical whispers dance. And for a final flourish, add time, because life, as a concept, is a kind of patience in motion. Whatever it isn't quick. Even if it begins quickly in some micro-oasis where warmth bathes molecules long enough for them to copy badly, its elaboration is a saga. It takes eons to invent good tricks, to rehearse the play of metabolism, to go from one trick to two, from molecular gossip to ribosomal factories, from nervous molecules to nerves. So potential life is not only a property of a place, it's a property of that place stretched along a generous timeline. You don't just want a habitable day, you want 1 billion habitable Tuesdays in a row. Against this checklist, the universe is startlingly generous. Consider the variety of homes it has already built in our single solar system. There's Mars, whose polar caps shiver with dry ice and water ice, a world once milder, grooved by rivers that wandered under a thicker sky. There's Venus, an earthly twin taller than its greenhouse catastrophe, carrying the memory of oceans in its isotopic breath. There are moons, so many moons, some with saltwater seas trapped under planetary-scale ice caps. Europa, with its cracked shell and possible hydrothermal vents. Enceladus, with geysers that spit organics into Saturn's winter light. Titan, with lakes of methane and ethane, laboratories for carbon in an alien solvent. None of these bodies are comfortable, and yet each one is a lesson. Habitability is not a single target, it's a spectrum. Environments dance across it. They stumble, they recover, they invent new ways of balancing their books. If this is how innovative a single star's family can be, imagine the neighborhoods around the galaxy. Imagine countless cousins of Europa under countless different skies. The unimaginable archipelago of icy moons orbiting gas giants that themselves crowd the temperate distances from faint red suns. Imagine super-Earths with continents jealous of Earth's teeny landmasses, worlds whose thicker gravity holds atmospheres with a lover's possessiveness, whose plate tectonics grind slowly but steadily, whose volcanoes feed skies with a gardener's patience. Imagine desert planets whose poles hide Earth-like summers once every tilt. Water worlds where continents never pierced the waves, but life found mountains of gradient at hydrothermal chimneys. Now take a breath, because imagining is dangerous. Debts accrue when dreams outrun proof. We promised ourselves realism, to keep the story honest enough that it could be lived. So, back to the arithmetic. The first number, stars. Our galaxy holds a few 100 billion. Beyond that, other galaxies make a scaffolding of light that stretches as far as instruments can chase. Numbers like these are boats that can carry any desire. But we'll keep our arithmetical calories lean, focus on this one galaxy, this one city of night. The second number, planets per star. Somewhere between one and who knows, some have none, some swagger with swarms. The third number, the fraction of those planets that are rocky. We are not snobs for rock, but we are honest about our ignorance. We do better when standing on basalt than hovering in hydrogen. The fourth number, the fraction of rock worlds in the right temperature range for liquid water. The fifth number, the fraction that actually have water, because habitable zone does not guarantee a drop. The sixth, worlds that hold on to their atmospheres and keep their magnetic fields or find ways to do without. The seventh, those that maintain these blessings for spans of time long enough for prebiotic chemistry to wake from its nap and ask for coffee. Each fraction erodes the total. It's a sieve. The old joy of the Drake equation, its cold-blooded turn, the crank doesn't give you an answer so much as it teaches you humility. The more carefully you think about each factor, the less able you are to swagger. But it also teaches you a subtler, deeper confidence that the universe does not need to be extravagant to be fecund. Even if each sieve catches most grains, the baskets downstream still brim. When you begin with hundreds of billions, your options for wonder do not evaporate under scrutiny. They refine. Let's step away from arithmetic to something messier, something that smells like laboratories and long afternoons. The origin of life. If potential life means a stage where chemistry can improvise its way toward biology, we must ask how hard that improvisation is. On Earth, the distance between molten nightmares and microbes was shorter than we once thought. Our planet cooled, oceans condensed, lightning scratched patterns across a young sky. Hydrothermal chimneys erected cities of mineral that conducted tiny currents. And, within geologically brief periods, tens of millions of years, not billions, there was life. Not in theaters or thunderstorms, not in feathered haste or flowering speed, but there, clinging, copying, arguing in molecular grammar. This does not prove the path is easy elsewhere, only that it is not impossible anywhere. It suggests that, given an audience, water, energy, elements, chemistry will try on costumes. Some won't fit, some will rip, some will be thrown in the wardrobe and never retrieved, but some will be worn to opening night. The possibility that life is a frequent accident follows not from wishfulness, but from the bland fact of time multiplied by scale. If you shuffle the deck of carbon across a galaxy of tables for billions of years, you will deal more than a single straight. Still, potential life is at least as much about what doesn't happen as what does. Consider the ways planets betray their own possibility. A star can flare like an angry god, stripping atmospheres and sterilizing surfaces. A planet too close can become a retreating lure of magma. Too far, a mausoleum of ice. A super-Earth can be too possessive, crushing atmospheres into high-pressure prisons. A sub-Earth too fragile, losing its air to cosmic pickpocket. Tides can lock one hemisphere in night and the other in noon, making the Terminator a ribbon of permanent dawn, the only temperate place to stand. Even there, winds can rage like perpetual sermons. And yet, even in these compromised worlds, niches can appear, polar regions relax, subsurface aquifers hide, caves giggle with warmth, chemistry finds corners to coo in. If the universe seems determined to invent hostile weather, it seems equally determined to invent hideouts. Extremophiles on Earth taught us that life builds homes out of discomfort. Stinging acidity, murderously high salinity, crushing pressures, scalding vents, blistering radiation. Everywhere we expected a stern no, life wrote a small italic maybe. So what do we do with that word maybe when we return to our galactic senses? We treat it like a multiplier. Every biosphere that tolerates an insult expands the roster of worlds that could, in principle, host potential life. Every weirdness that life survives on Earth translates into one fewer excuse to dismiss another planet. Of course, nature also has a taste for accidents too catastrophic to finesse. Mass extinctions remind us that potential is not a promise. Asteroid strikes, flood basalts, runaway greenhouses, snowball ages all can close curtains abruptly. Yet even here, something instructive glimmers. Extinctions prune. They also reset the stage for novelties. If life emerges often, then it may also re-emerge often, not as a phoenix from ashes too romantic, but as a stubborn weed from the cracks. Potential life is not a slogan, it's a capacity to try again. I want you to notice something about the way your pulse responds to these thoughts. There's a rhythm to possibility. You imagine a fertile world, then you learn a way it can go wrong. Then you discover a workaround life might employ. It's not sentimental optimism, it's systems thinking applied to a biological itch. Planetary habitability is a set of feedbacks, levers, and traps. Potential life is the art of threading through them. Planets, like people, can be both fragile and resilient, both precarious and resourceful. The question, do most planets harbor potential life, rests on that human analogy. We know the world can be harsh. We know life can be adaptable. When you scale those truths to cosmic proportions, you get a galaxy that is neither Eden nor desert. You get a galaxy with weather. Indulge one more perspective shift. Leave the galaxy. Look back at it as a smear of light. Inside, billions of stars. Around them, billions of worlds. Between them, dust that will one day be rock again and breath again. Does that smear look like a place where life is rare in principle? Or does it look like a place where the improbable keeps buying more tickets because there are so many raffles? We must resist poetry masquerading as proof, but sometimes the number of tickets is the proof. Probability is not a spell, it's the patient voice of the universe speaking in statistics. It says, give me enough tries. There's a reason your species built radios and telescopes and launched polished mirrors to wait in the cold. You understand intuitively, stubbornly, that silence is not evidence of emptiness. Silence is just what it sounds like between first questions and first answers. For now, we paddle the shallow end, atmospheric chemistry measured from light years away, the faint fingerprints of gases that on Earth would be called out as biosignatures, the tricky problem of telling life's breath from geology's sigh. We scan the reflected colors of distant skies and ask if the palette leans toward biology. We stare at the heat of young planets and listen for the soft purr of volcanoes writing stories into air. The work will take generations. It already has. You may not be alive when a confident answer arrives, but you are alive for something else. The moment when the question is no longer either naive or unaskable. That counts. That is not a consolation prize, it's an era. You are the first creature not just on Earth perhaps, but anywhere to stand under a sky, point to a star, and say, with instruments to back your audacity, that star almost certainly hosts planets, and some of those planets are rocky, and some of those rocky planets sit in temperate light, and some of those temperate worlds have the raw inventory that makes chemistry restless. This is the arithmetic of breathing worlds. Stars by the 100 billion, planets by the trillion, habitable zones like sashes of mild gold around them, raw materials that are not exotic but ordinary. Carbon is not rare. It's a generous letter in the cosmic alphabet. Nitrogen is not a boutique offering. It is a friend that shows up uninvited and stays late. Phosphorus is stingier, yes, a chaperone that makes you work harder but not absent. Sulfur is a trickster but necessary. Hydrogen is everywhere, oxygen a gossip that loves to get involved. The universe is not starving us of the pieces, it dares us to assemble them. So, do most planets harbor potential life? The cautious answer asks for definitions, margins of error, error bars thick as tree trunks. It whispers that most is ambitious and potential is slippery. But the honest answer, the one that leans into the arithmetic, that respects what we've learned without pretending we've learned more than we have, is this. If by potential life you mean a plausible chemistry set under temperate light with energy at hand and time to tinker, then yes, the cosmos seems to tilt that way. Not because it loves life, not because it has intentions, but because it is generous with places and stingy with certainties. Even if only a modest fraction of worlds are truly promising, the baseline population is so high that modest inflates into many. If you insist that most must mean 50% plus one, I'll keep my voice measured. Maybe not most, not by that rigid tally. But if you mean so common that we will one day grow bored listing them, then I am ready to bet the kind of bet a scientist can make. A bet of work, of attention, of lifetimes pointed outward. Stand with me on a beach at night. The sea salts your lips. A breeze lets your jacket flatter your ribs. Overhead, Orion is assembling himself star by star. You look up and think of lungs. Not human lungs, not yet, but the first lungs. Thin films of water around volcanic beads, microenvironments where wetness and warmth and mineral surfaces made a small conspiracy. Those were the universe's first inhalations on this world. They were probably not unique. The universe has lungs hidden everywhere. We haven't yet learned to listen. In the shadows of craters, in the warm glows under ice crusts, in the hazy twilight of time-locked planets, in the pores of rock, a kilometer deep, where pressure makes patience. I promised realism. Here it is. Most of what we imagine will be wrong in detail and right in kind. We will be surprised, as we always are. Some planets will trick us. We will swear we detect oxygen from life, and discover it is geology in a flashy suit. We will dismiss a world as sterile and later learn its seas giggled with unfamiliar biochemistry. Our models will overfit, our instruments will lie, our pride will take stitches more than once. But the long curve will bend toward abundance because our starting condition is abundance. Abundant stars, abundant worlds, abundant time, abundant ways for the same elements to learn new dances. There is one last arithmetic that matters, and it is not cosmic but moral. When you believe that potential life is common, you begin to see your own planet not as a solitary miracle, but as a local instance of a general tendency. Matter flirting with meaning. That view can cheapen Earth in some imaginings, as if rarity is the only metric for reverence. But I think it does the opposite. If life is a common fire, then each hearth matters more, not less. If there are many seed beds, then the stewardship of each garden is not a privilege but a duty, because any garden can go fallow if miskept. Knowing that oceans are cosmically ordinary does not make this one less tender. It makes it a member of a choir we might one day hear. What a shame to sing off key. And so, when someone asks you over coffee at midnight or in a comment under a video, do most planets harbor potential life? You can answer like this: the universe is extravagant with places where life could begin. Not a few, not a rarity that must be coddled by myth, but a multiplicity that almost offends the modesty of our imaginations. We have not yet heard the universe laugh in the voice of another biology, but we are learning where to put our microphones. We are learning the rhythm of worlds that can breathe. Turn the page, then. In the chapter that follows, we will leave arithmetic for fingerprints. We will ask how to recognize potential life from far away, how to read a planet's air like a diary, how to separate the breath of a forest from the false confession of a volcano, and how a handful of telescopes, mirrors in exile, eyes that never blink, might teach us to count gardens we cannot visit. The universe has already been patient with us. It will be patient still. Our work is to learn how to listen without inventing what we wish to hear. For now, you do not need an equation. You need a feeling that we can discipline into knowledge. Stand under the sky. Count badly on purpose. Imagine an ocean. Imagine another. Imagine 100 more. That is the arithmetic of breathing worlds. That is the first answer to the first question. Chapter 2. Reading the breath of distant shores. If Chapter 1 was arithmetic, how many worlds and how wide the odds, then Chapter 2 is literacy. Not the literacy of letters and sentences, but of starlight and air. If we're to say anything honest about whether most planets harbor potential life, we must learn to read a planet without touching it. We must cultivate a second sight that can look across light years and say, this world is not only real, not only rocky, not only warm, but restless in a way that chemistry alone rarely sustains. We must learn the subtle grammar of atmospheres and the punctuation of clouds. Start with the most stubborn fact. Planets don't send us postcards. They do not announce their temperatures on roadside signs or publish their oxygen levels in polite brochures. What they do, what they cannot help but do, is filter and reflect and emit light. When a planet passes in front of its star, some of the starlight threads through the planet's atmosphere, if it has one. That light is combed by molecules, tugged at by their vibrational whims, and those tugs leave fingerprints. When the planet slips behind its star, the combined glow dims by a whisper. Compare the before and after, And you've learned what the planet itself contributed: a haze of heat, a tint of cloud, a whisper of chemistry. When the planet simply swings through its day and night, its face brightens and darkens in a pattern that betrays continents and oceans, or at least, if not a map, then an attitude toward light and heat. This is not magic, it's spectroscopy, and it is our promised literacy. Imagine a prism so delicate you can tell when light has been asked to sing through methane. Imagine a mirror so patient that it can notice the absence of brightness and turn it into a surface map. That's the level of intimacy we can have with a world we will never touch. But literacy without skepticism is superstition. The mist we're reading is a liar when we're careless. Oxygen, that sacred emblem of life on Earth, can be forged by sunlight cracking water on a desert world, the hydrogen fleeing and the oxygen sulking in the sky, building to abundance, without a single leaf needing to exhale. Methane, that suspicious cousin of swamps and stomachs, can be belched by volcanoes. Nitrous oxides can arise without a farmer or a bacterium within 100 million miles. A false positive is the easiest story to tell when you are desperate to hear a yes. So we must read not single words, but sentences. Not oxygen alone, but oxygen with a counterbalancing partner, a gas that seems allergic to oxygen and therefore requires constant replenishment to coexist with it. Not methane alone, but methane with carbon monoxide at constrained levels, or with patterns of seasonal variation that track a planet's tilt and weather like a heartbeat. Not pigment alone, but a pigment that absorbs just where starlight makes it sensible for a photosynthesizer to drink. In short, we look for disequilibrium, for planets that seem to be exerting themselves to maintain contradictions that simple geochemistry would let collapse. Disequilibrium is the cosmic equivalent of tidying up after guests have left. It takes effort. It implies metabolism. On Earth, the sky is a negotiated truce. Oxygen should react away, but forests and phytoplankton keep riding it back into the air. Methane should oxidize, but some bodies still burp it out, and microbes top up the breath. Our climate is a braided necklace of feedbacks, not a single unbroken chain. Learning to read such braids elsewhere is the work of telescopes, yes, but also of humility. We do not assume we know all the ways a planet can cheat the odds. We assemble libraries of atmospheric stories, some biological, some geological, some photochemical, and we practice telling them apart. There is a romance to this work, even in its caution. Picture a planet 100 light-years away. Its star is small and calm. The planet completes a year in a span of weeks. We watch the starlight thin during a transit and thicken afterward, thin and thicken again for years. In our graphs, the star pulses like a steady drum, the planet a rider on that rhythm. We compile the spectrum, a comb where some teeth are missing. Those gaps aren't absences, they're signatures, the places where molecules drank. We hold that comb against our wall of known signatures: water vapor, oxygen, ozone, carbon dioxide, methane, hydrogen sulfide, sulfur dioxide, the noble gases, and we begin to suspect a story. Then we try to disprove it. Then we try again. The romance is not in the first yes. It's in the last no that we cannot make stick. You might ask, what about the worlds we cannot read this way? Planets that do not transit, or whose air is thin as a postcard, or whose clouds are so boisterous they smear any spectral secret into mush. Cleverness recruits other senses. We watch worlds wobble around their stars and derive masses. We watch how their days warm and their nights cool as they turn and learn heat capacity. Oceans hold warmth like hoarders, while deserts spend it fast. We look for glint, the sudden flash of mirror-bright surfaces. On Earth, a sun glint is a signature of an ocean, though other surfaces can flirt with our hope. We wait for storms so grand they alchemize the planet's light curve, hinting at weather cycles that could carve rivers or lay down dunes. We listen to radio emissions that might, in the wildest luck, betray lightning, or the dance of a magnetosphere strong enough to hold back a star's tantrums. We sketch, erase, and sketch again. All this because we're after a generous claim, not simply that life exists elsewhere, but that potential life, seedbeds, incubators, laboratories, is commonplace. To argue that, you count signatures of invitation, long-lived heat, patient oceans, atmosphere within bounds, nutrients delivered by hungry geology. Some of these you can infer from the way light warms a face, some from the way an orbit refuses to break, some from the way a star's personality shapes its family. When we say most planets may harbor potential life, we mean we expect to find such invitations often enough that our definitions of rare will need recalibration. But the universe rarely lays out a single kind of welcome mat. One world may roll out the blue carpet of a shallow sea, another orders its invitations in the under-ice mailroom of a moon circling a distant giant. In our own home, we have examples of these monasteries of possibility. Europa, with its cracked white shell and undersong of tide and vent. Enceladus, whose fountains carry whispers of organic molecules into a ringed afternoon. Titan, where methane plays at being water, sculpting shores and weather that confound our earthly bias toward oxygenic life. Mars, that rusted memoir whose pages still crackle with the rumor of ancient rivers and aquifers, and perhaps, in deep basalt, the final stubborn signatures of chemical restlessness. If our single star can offer 4 or 5 different kinds of invitations, then the galaxy whose red dwarfs are stingy with brightness but generous with time likely offers millions. Long-lived stars are good landlords. Even a world tidally locked, cheek warmed forever by its star and the back of its head forever in night, might find temperate twilight around its terminator, a band of eternal dawn where air can circulate and water can flow. Winds would work like conveyor belts, dragging heat from day to night and back again. Weather would be a perpetual compromise. Life, if invited, would learn the art of compromise as a native tongue. All that invitation, all that variety, none of it answers the deeper dread that sometimes gnaws at the optimism of numbers. If potential is common, why don't we hear the chorus? Why is the night so quiet you can hear your own speculation echo? This is the old paradox in a new coat. But remember what we are claiming here. We are not claiming that most planets host civilizations with antennae or appetites for broadcast. We are not even claiming that they host complex life or forests or fish or fables. We are making a narrower, stronger claim that most planets have or will have stretches of time when conditions are favorable for life to begin or to begin again after a catastrophe, or to dawdle forever in the long twilight between chemistry and biology. That is a claim about soil, not orchards, weather, not songs. Soil does not sing, weather does not compose symphonies. Silence is not a disproof. Even if we widen the claim, dare to suggest that simple life might be common, the translation to audibility is fraught. Microbes do not build radio towers, they alter their air, perhaps, and we are learning to eavesdrop on that. But a galaxy full of microbial meadows might still sound like a library at midnight. You would need to learn to read the margins to know you were in a place where life had left fingerprints. A little oxygen here, a seasonal burr there, a pattern of cloud whitenings that hints at biotic aerosols, which is exactly what we are doing, teaching ourselves to hear whispers without inventing them. In that spirit, imagine the first planet for which we cannot wiggle free from the conclusion. Its air is in disequilibrium that geology alone would struggle to sustain. The team will be careful. They will offer alternative stories and knock them down one by one. The announcement will be dry. No one wants to be the person who cried life. But the relief will be a kind of music, not because we have found aliens, but because we have finally met a world that refuses to hide its invitation. That day will change our calendars less than it will change our pronouns. We will speak of worlds that can, not worlds that might. And once we have one, others will follow. A catalog will accumulate planets whose airs read like prefaces to biographies. What then? Our question, do most planets harbor potential life, will not suddenly be answered with a neat fraction, but its bias will tilt. Before, we could argue that Earth is a strange stroke of luck in a catalog of deserts and furnaces. After, the null hypothesis, sterility unless proven otherwise, will seem less dignified. The universe will look less like a warehouse of silent stones and more like an allotment garden, where not every plot blooms, but every plot had the seed packet taped to its gate at some time or another. We must also admit an ignorance that is almost delicious. We do not know how many doors into life the universe has built. We know one door well enough to be humbled by it, the carbon water door, lit by stars whose tantrums mellow over time, guarded by magnetospheres and moderated by tectonics. But there might be other doors, opened by solvents we sniff at, by chemistries we have written off as inconvenient, by energy sources we cannot yet imagine. A universe with many doors increases the set of worlds that qualify as potential by orders of magnitude. A universe with a single door still does not starve us. In the practice of science, slogans are suspicious, but some ideas work like portable scaffolding. You can carry them into any new room and find they hold. Here's one: life exploits gradients. Where there is a slope from hot to cold, reduced to oxidized, ultraviolet to deep shadow, life can wedge itself and drink. Planets are gradient factories, day divided by night, pole divided by equator, surface divided by mantle, ocean divided by sky, vent divided by seafloor. Even dead-appearing worlds may harbor gradients that simmer quietly, below, within, in cracks and pores. If most planets, at some stage of their lives, manufacture such slopes and protect them from immediate erasure, then most planets harbor potential life, not as a poetic guess, but as a mechanical consequence of physics written on rocks. When the numbers exhaust us and the caution cools us, it helps to return to a human scale. Picture an early Earth shoreline. The tide has misread its watch and arrived late, so pools are stranded here and there, hot and a little cranky. A bit of ash from a far volcano has seasoned the water with metals. Lightning engraves its short manifesto. A meteor adds an exclamation point and is gone. In a pool you would pass without noticing, Molecules practice loyalty. They stick to a mineral's face for a moment longer than they did yesterday. They learn to couple an energy-releasing reaction with a scaffolding-forming one. A small ring of atoms discovers it prefers to exist in the plural. Copies flawed, seductive, promising, accumulate. You have witnessed in that image the central miracle made mundane by scale, order wedging itself into chaos, long enough to try again. The ingredients were not rare. The stage directions were not impossible. Given time, given repetition, remember the arithmetic, this scene was inevitable under some sky, somewhere, perhaps under many. And yet our responsibility blooms in the same light as our optimism. If potential life is common, if seed beds are strewn like stars, then our garden is not a VIP lounge, but a local chapter. Its importance increases. It becomes one data point among billions that will never speak for themselves. We are their possible voice. If we scorch this place or silence it, we are not merely ending a local story. We are interrupting the larger conversation we desperately want to join. Stewardship, in that view, is not sanctimony. It's strategy. We want to arrive at the choir as singers, not as the ghost of a missed note. The arc of this book is short on purpose. 2 chapters to hold one question in both hands. First, the arithmetic of breathing worlds, then the literacy of reading their breath. What can we say at the end and still sleep well under our sky? We can say this: the universe has made planets as if it could not stop itself. Many of those planets are rocky. Many of those rocky worlds spend long seasons in temperate light. Many of those carry waters and winds. Many of those maintain gradients and cycles. Many of those will hold those conditions long enough for chemistry to attempt something more ambitious than weather. That accumulation of many of those is what we mean by most. Not a formal vote with a tally master, but a bias written into the structure of things. The cosmos, indifferent yet generous, supplies the opportunities. Life, indifferent yet stubborn, takes them. If you are listening to this as an audiobook, perhaps walking a night street or sitting by a window mid-afternoon, here is your closing invitation. Look out at neon reflected in puddles, at branches misquoting the wind, at a neighbor's cat gazing with indecipherable industry, and remember that potential is not a cheap word. It is expensive, purchased by time and by the patience of laws that let complexity linger. We live in a universe that pays that bill often. If most planets harbor potential life, it is because physics and chance have together invented a factory for maybes. We, meanwhile, have invented instruments for turning maybes into measurements, mirrors that do not blink, radios that drink static and return pattern, algorithms that refuse to be charmed by our biases. We are at the beginning of an age of planetary reading, an age when catalog numbers will acquire biographies and where the word habitable will fracture into subgenres. Habitable for microbes under ice, habitable for forest in principle, habitable once upon a time, habitable in twilight bands, habitable by chemistries we have not yet met. The taxonomy of possibility will be untidy and glorious. It will outgrow our lust for neat conclusions. It will be worth the work. Do most planets harbor potential life? I think you know now how to answer. Not with a number that calcifies debate, but with a posture, a leaning toward yes sharpened by caution, a readiness to be surprised, a gratitude for abundance that refuses to become arrogance. We will be wrong, often, in the details. We will be humbled by atmospheres that trick us and by deserts that bloom in chemistries we doubted. But on the day our telescopes finally corner a sky that breathes in a way geology alone cannot explain, we will feel less astonishment than recognition. Of course, we will say. Of course, the universe offered another garden its quiet permission. Close the book, then. Keep your eyes open. The night has never been empty. We are merely slow readers. We can learn. We are learning. And somewhere, on most of all those worlds we will never visit, the conditions required to try have already come and gone, or are gathering now like hands around a match. They are, however, honest. And honesty, in a universe like ours, is a form of love. Before I left the river, a breeze slid under the bridge and lifted a sheet of newspaper into the air. It fluttered, stumbled, snagged on a branch, then loosened and sailed on. Somewhere, people were laughing, not because they had solved anything, but because solving was not required to enjoy the evening. The moon was up, bearing its old scars like medals. The city performed its symphony of small endings. Last trains, last glasses, last emails sent with too little thought. I stood and put my hands in my pockets, the way a person does when words have run out. Here is where our book ends. If you were hoping for fireworks, I can only offer you fireflies, smaller lights, closer to hand, arranged by chance and will into dances that mean more than they have any right to. The universe will do what it will. We will do what we must, and sometimes what we can. Between these, meaning grows like a weed through concrete, uninvited, unstoppable, stubbornly green. When the question woke up, it woke us with it. We answered as far as the morning allowed. We found that beginning and end are not cages but contours, and that living inside them can be not only bearable but beautiful. If the cosmos started in light and will end in night, then we are the candles in between. Hold one up, look around, see who else is holding one too.